Today we're doing the seventh set of notes, which is about the theorem about roots, and this is going to be our first day on this set of notes. So to determine the number of possible rational roots, we take our factors of your constant term, and you divide it by your factors of the leading coefficient. So you're taking the factors of your constant term and dividing it by the factors of your leading coefficient. And just a quick recap on this vocab words. Your constant term is the number without an x, and your leading coefficient is the number in front of your x with highest exponent. And when I say factors, what I mean is all combinations of values that multiply together to give you that number. So like for example, if my constant term was 8, I would say 1 and 8, 2 and 4. And then we would address all the positive and negatives. So let's go ahead and take this and apply this to a problem. So letter A, it says 2x cubed minus x squared plus 2x plus 5. So I know this looks like a problem that we've done before because it has the 4 terms. However, if you tried grouping the first 2 and grouping the second 2, or put all 4 terms in the box, you're going to notice that it's not factorable. Like my 2 combinations will never match up. So remember how we talked about when we did the quadratic chapter, like I picked problems on purpose that worked out. So same thing in that last section we just tested on. I made sure they worked out nice. So here's an example of one that does not work. It's still solvable, it's just not factorable. So we make our list. So my constant term is 5, and my leading coefficient is 2. Okay, so the numbers that multiply to be 5 is a 1 and a 5. And the reason I put the plus or minus there is a positive 1 and a positive 5 work, and then a negative 1 and a negative 5 also gives me the positive 5. Divided by factors of my leading coefficient, so this is plus or minus 1 and plus or minus 2. Now, setting it up is half the battle. Now we need to go through and figure out like my ultimate list. So you want to have some kind of strategy when you do this. So I'm going to start with my top numbers. I'm going to take this 1 and divide it by both bottom numbers. So 1 divided by 1 gives me 1. 1 divided by 2 gives me 1/2. So now I've taken that top number and divided by both numbers. So now I'm moving on to the next top number, which is 5. So 5 divided by 1 is 5. And then 5 divided by 2 would be 5/2. Okay? So once you set it up, it's important that you divide it out to get your ultimate list. So of these 8 numbers, one of them or potentially all 3 of them are zeros or solutions to this function. We just need to figure out how. So go ahead and try letter B, make your list. When you're ready, hit play in the video. All right, so now we're going to take that concept that we just practiced and put it towards use and actually show you how to solve the problem. So again, if you try to factor this problem's not factorable, but we can solve it. So my constant term is 2, leading coefficient is 15. So my factors of 2 are 1 and 2, and my factors of 15 are plus or minus 1, 3, 5, and 15. And yes, all of those get plus or minuses, but it is okay with me if you just write it one time in the front. It's implied to go to all of them. So now we need to divide our list out. And remember I talked about having some sort of strategy. So I start with my top number, and I'm going to divide it by all 4. So 1 divided by 1 is 1. 1 divided by 3 is 1/3. 1 divided by 5 is 1/5. And then we have 1/15. Then we're going to go through and divide by 2. So I get 2, 2/3, 2/5, and 2/15. So what we do with this list is I would plug them in, and I'm looking for the one that gives me 0. So basically I'm trying to figure out of these values which one of them is a solution. So for the sake of time, I'm going to give you one of the solutions, and then obviously when we have access to a calculator, I'll show you how to sit here and plug them all in to figure out which one actually works. So if I were to plug in f of 2, so I'd have 15 times 2 cubed minus 32, 2 squared, plus 3 times 2 plus 2. So 2 cubed is 8, and then 8 times 15 is 120. Then we have, so 2 squared is 4, and then 4 times 32 is 128. Then I have plus 6 plus 2. So if I add up all my positive numbers, I have 128 minus 128 is equal to 0. So I've determined that the value of 2 is a solution to the problem. So the reason this is a benefit to us is I can use this value, do synthetic division with this value, and know that I'm going to get no remainder because it is an answer to this problem. It is what we call a factor. So we're going to do synthetic with the value of 2. Notice I'm not changing the value to be -2 because 2 is the 0. I'm not taking it from a binomial. I've determined that it is an answer. And I take my coefficients of 15, -32, 3, and 2. So I drop my 15, multiply, I get 30, add, I get -2, multiply, -4, add, I get -1, multiply, -2, add, I get 0. So now I've dropped it down to the second power. So I'm now dealing with 15x squared minus 2x minus 1. And I know that if the answer 2 is a 0, so since I know that this is a 0 here, I can assume that it came from the binomial of x minus 2. Do you have to write that? No. You could just stay right off the bat that you know one of the solutions is 2. And now we need to work with this. So I'm going to flip the screen so I have more room to solve this next part. So now we're dealing with 15x squared minus 2x minus 1. And now it's regular old factoring. So a times c is -15. I'm dealing with a 5 and a 3. My 5 needs to be negative. So I'll have 15x squared minus 5x plus 3x minus 1. Again, if you're boxers, go ahead and put those 4 terms in your box. I'm doing it the grouping way. I can take out a 5x. I'm left with 3x minus 1. Take out a 1, left with 3x minus 1. So this factors down to be 5x plus 1 and 3x minus 1. And remember that I got the answer of 2, which I know comes from a binomial of x minus 2. But the ultimate goal for doing this is to solve, so I want to know what my answers are. So I will get -1/5 from the first binomial, +1/3 from the second, and the answer of 2 from the third. So to kind of recap what we did, I'm going to go back a screen real quick. We made our list of possible zeros. Notice the answer of 2 is in the list, 1/3 is in the list, and 1/5 is in the list. typically we don't plug in fractions, we try and plug in our whole numbers. And the whole purpose of plugging that in is to take something that was to the third power and drop it down to the second power. Because the moment we're in the second power, we can factor or use quadratic formula. So that's all for today. I would like you to try letter B and then input your answer when you are done that problem.